Hi there, everybody. I wanted to show you how we can use patterning with an understanding of what is happening with numbers to be able to predict where they're going. These representations help to give us the background to understanding what goes into an algebraic formula that we all knows that the kids will need to use in the intermediate grades and going into high school. But it's very important, just as with any algorithm, that we understand the background behind them. So for sake of trying to keep this as quick as we can, I have a visual pattern here from the website visualpatterns.org. And I pulled up this linear growing pattern right here. And that is what we're focusing on to start, our linear growing patterns. I am identifying with the students what the constant is and what it is going up by each time. And we're showing this pattern in a lot of different ways. Being able to show what is happening with a pattern is key to understanding what the numbers are doing. And we can look at it with a lot of different tools. So we're going to be using each of the tools to help to build that understanding. So when we ask for the word constant, that means what is unchanged through this whole thing. So I'm going to also first tell you the terminology here that when I look at each group of pictures is called a term. So this is term 1, this is term 2, and this is term 3. In term 1, I have 2 ghosts. That constant stays the same through each of these. I will always have those 2 ghosts in each of the terms. So that is why we call it a constant, because that does not change through the whole thing. And then we see what's happening with the pattern by saying how much is it going up by each time. So in term 1, I had 2. In term 2, I have 5 ghosts, 1, 2, 3, 4, 5. My constant was 2, so I went up by 3 ghosts. And we can see that here. There's 3 ghosts here. And then I also went up another 3 this time. So I have 3 and 3. So term 1 has 2, term 2 has 5, term 3 has 8 ghosts. That's just helpful for us identifying what is happening in our pattern rule. So when I jump here, I can say that we started at 2. We increased our pattern. This is an increasing pattern. It means it is getting bigger, and it is getting bigger by 3 each time. And this is called a continuing pattern. It means that it would never end unless I tell it to stop. So this is helping to identify the pattern rule, which is very important. Now, if I were to say, can you tell me what term 4 would be? Many students would get out and they would draw the next term. So they would draw 8 and then add on 3 more, and so that they would have 11 ghosts. And that's fine for very early stages for kids to understand how to extend the pattern so they can predict what comes next and what comes after that. Eventually, we get to a point that drawing all of these ghosts is very time consuming. And then you get to a point where you feel really badly for the kid because they're just drawing so many things and then they start making mistakes. And that's not an efficient way of showing where the numbers are going. That's why we use algebra. But let's use some other tools to help identify where they're going. So one of my favorites is by showing a 100 chart on here. I have a tool right here that links us to a website called ABC that opens up an interactive number chart right here. And this is very easy to use. So in term 1, I had 2 ghosts. Term 2, I had 5. Term 3, I had 8. So let's build that in. 2, oops, sorry, I need to give it a color. 2, 5, 8. I'm increasing by 3 each time. So that means term 4 would have 11. Term 5 would have 14. Term 4 would have 17. Term 4 would have, or 7. 1, 2, 3, 4, 5, 7 would have 20. Sorry, I was getting mixed up there. But now I can see, instead of drawing out the ghosts every time, if I were to draw this out 7 times, I would have 20 ghosts. But I can now see a pattern starting to develop in this 100 chart. I don't know about you, but to me, it looks like they're going down on an angle. So do I need to keep counting by 3s? 1, 2, 3, 1, 2, 3. I don't know about you, but I can just start seeing what's happening with the pattern and filling it in. These visual representations are really important for the kids to be able to see the beauty of the math, because then they can start predicting and identifying where it is going. So then when their 100 chart is completely filled in, it should look something like this. Now, if I were to say, here's term 1, term 2, actually, I'm going to color those differently. Let's color those in pink. 1, 2, and 3. Those were given in our pictures. But I extended the pattern. So here's term 4, term 5, term 6, term 7, and so on. If I were to say, what is term 12, I could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That would be my term 12 would have 35 ghosts. So if I were to draw these pictures 12 times, I would have 35 ghosts in term 12. If I say, what is term 17? So this is 12, 13, 14, 15, 16, 17. My 17th term would have 50 ghosts. If I were to draw these pictures 17 times, I would have 50 ghosts. Do you see how this is much more efficient than being able to draw this over and over and over again? This is a much better way of learning. So I'm going to copy this and I'm going to paste this into my slides just so that I can show my work. Oh, it's not letting me do it here. Paste. There we go. Just so that I can show my work in here. And it shows that I can go here. Mrs. Newbern can ask questions. What is your 12th term? And they can answer it would be 35. We've already answered our pattern rule with this, but we can also use a number line. This is a website called the Math Learning Center. This has an interactive number line on it. With this, I'm going to show that I have 2 to start. Can I make that in red? And I'm going to just move my 2 right here. So I started at the number 2, and I increased by 3 each time. So that is not by 3. I need to drag this so that it's at 3 so that my second term had 5. And now I can see it is increasing each time by 3. Now, if I took the time, I can fill in the number 3 on each of these so that you can see it's going up by 3 each time. I'm not going to take that time for this. But now I can, in here, like our 100 chart, I can see what is happening in each of my pictures. Term 1, I had 2, so that was term 1. At term 2, I had 5. At term 3, I had 8, and so on. And so then here's my term 4, term 5, term 6, term 7, term 8, term 9, term 10, term 11. Just for giggles, let's see if term 10 was 29 when we also look at our 100 chart. So if that was my term 10, let's go back to the 100 chart and see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I had the number 29. That is in fact correct. So we could look at it on the 100 chart. We can also look at it on a number line, and we can see what is happening with our pattern on a number line. These are just 2 different ways of looking at it, but it helps us to understand what is happening in our patterns. So I can take this, I can copy it as well. I'm just doing screen captures, and I can paste it in to here to show my thinking. And so here is a number line. Those are 2 different ways of looking at our patterns. Another way here, I pre-built this for sake of time, but another way would be to use a graphing tool. You don't actually need to fill in all of these little dots, but the dots show you what is happening in the pattern. In term 1, I had 2 ghosts. You can see that here. I'm going to present the screen so you can see that. In term 2, I had 5 ghosts. So you can see my 2 ghosts plus 3 more. In term 3, I had 8 ghosts. So here's my 2 ghosts, adding 3 and adding 3. And you can see it's doing that each time. So I'm just going to take, oops, sorry, I forgot I'm in presentation mode. So you can just see that you don't actually have to fill in all of these dots, but it does give you an indication of what is happening in our pattern as we go along. So I can use this to predict where things are going. So for example, if I didn't know what was at term 5, Sorry, I don't want to do that. If I didn't know what number was at term 5 and this little guy was not here, I would just look along the trajectory of my number line and I would say, oh, if I look at term number 5 and I follow it all the way up until it intersects the number line, I get the number 14. Does that match? If I say term 5, would it have 14? Well, let's take a look at some of our other patterns. 1, 2, 3, 4, 5 has the number 14. 1, 2, 3, 4, 5 has the number 14. So that does match up. This is another way to see what is happening at the pattern and to be able to use this tool to project and predict what numbers would be coming ahead. And this line would just keep going right off the chart forever and ever. And so there is an interactive graphing tool right here. I'm not going to take the time to show you how to use it just for sake of time on this video, but for concept purpose, you want to be following the trajectory that our linear growing pattern is going. I'm going to be honest, not every pattern is linear. They're not always going to make a straight line, but for this purpose, we are using linear growing patterns. And then finally, I want to show you here as well where we are going toward our algebraic expression. We're going to start by looking at the t-chart in our white zones right here. So let's fill in the information that we know. Term 1 had 2 ghosts. Term 2 had 2 ghosts plus 3 more, so I had 5 ghosts. Term 3 had 8, term 4 had 11, term 5 had 14. What if I want to know what is at term 100? That's all this n means, is I can replace my term number in asking which one I want it to be at. So if I want to know what is at my 100th term, I would put that in. Let's maybe for this sake look at what would be in my 7th term. We can look at our 100 chart right here and say my 7th term would be 20. So let's test and see how we can make an algebraic expression to see that it works. What we did was we plugged in our information and we can see that we were increasing by 3 each time. When you have repeated addition, that is the same thing as multiplication. Repeated addition is multiplying by 3 every time. So we're going to take that 7th term and we're going to multiply it by 3. The problem is 7 times 3 is 21. But we can see here that our answer is 20. So 21 cannot be true. So we have to make an adjustment. This is where this part comes in right here. Is we need to, I can tell you that the next part is -1. And the way we do that is we need to kind of back up because we didn't start at a value of 0. We started at a value of 2. So if we were to go back to a term before where there is no term, and we were to take away 3 from that 2, so here's my 2, and I subtracted 3, I would have -1. Here is my adjustment right there, the -1. So let's try this. If I were to say, what is my 7th term? This would be 7 times 3 minus 1 equals 20. That works because I could see 20 right here. Let's try this with the 12th term. So I'm going to take that 7th term out. I'm going to put in my 12th term. So let's replace the n for 12 times 3 minus 1. So 12 times 3 would be 36. We're going to take away 1. That is 35. Let's see if that works. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. My 12th term is indeed 35. So this is how we can create an algebraic formula. The algebraic formula allows us to go way bigger than these representations in a way that is more efficient for us to use. But we needed to understand how that algebraic formula is made in order to use it. So now, if I want to know what the 100th term is, I can replace n for 100 times 3. So that would be 300 minus 1 would be 299. I don't know about you. I don't want to be building out these 100 charts that many times, but my answer would be 299. And you can see how that formula allows me to go much greater than the representations that we have. But these representations help us to be able to understand what is happening in our pattern. Every one of these allows us to predict what the number is and where it is going. This is also going to be very useful for real life applications. I could ask, would you rather have $2 a day and increase by $3 every day? Or would you rather have $1 million and then put it by a certain date? We can use our algebraic formula for money and financial and planning and for real life applications. In this case, I'm using it to be able to see what is happening in these pictures. We're going to be starting with picture representations. We will be changing the types of patterns as we go, but this gives you a little bit of a foundation of where we're going. I'm going to leave this video here because this is long at this point, but I hope that you had a good understanding about what is happening at this point. So I'm going to make this a little smaller. We weren't looking at our 12th term there. We were looking at our 100th term. So our 100th term would be the answer, 299. So I just hope that that helps to give you a visual about what is happening in our standard algorithms. Thank you very much. I hope you enjoyed and have a great rest of your day.